reinforced concrete beam, T-shaped beam sections. So in this example, we want to review a T-shaped section in terms of nominal moment, a capacity of the section for a T-shaped section with the F prime C, Fy, and area of steel, and also effective uh, width of flange provided to be 48 inches. Let's see how we can approach this problem. So in this problem, we have a floor which is consists of 20 reinforced concrete T-shaped beams with below dimensions, as you can see in the figure. If the effective flange width, that's BE, equal to 48 inches, and also we do know the area of reinforced steel is 77.25 inches squared. We want to calculate the nominal moment capacity Mn of the section is what? Is of ACI code. So in this example, F prime C provided to be 3000 psi, yield strength of steel is 60,000 psi, area of steel provided to be 7.25 inches squared, and effective width of flange is provided to be 48 inches. So also BW is a width of web is 12 inches. These are the information we have to calculate the nominal capacity of the section, nominal moment capacity. So the very first check in a T-shaped section is to calculate a depth of A if you assume our section is just a single rectangular section with the height of a D and width of B or B. So in this case, our A is AS times Fy over 85% of F prime C times B. So then the second stage is to make a comparison between your calculated A based off a rectangular section and the height of flange. If your A is less than half height of flange, there is no need to do anything in regards of a T-shaped section because you're not entering to the web of T-shaped section. But if your A exceeded the height of flange, it means you already entered to the web of a T-shaped section, the narrower part of the section. So you need to do the analysis based off a T section. So in our problem, area of steel provided, a 60,000 is the Fy, strength of steel 85% of a F prime C times a B, which is provided to be 48. That's effective flange widths. Because when you create the rectangle, that's based off a width of flange, and it just gives us a height of equivalent block equal to A is equal to 3.55 inches, and that's definitely higher than height of flange, which is 3 inches. You can see here easily. So it means our section need a T-shape analysis. So in doing so, we need to dissect our section into two parts. One part is responsible for the a rectangle with the height of a effective depth and width of a web, and the other part is the part which is responsible for the flange part. So that's a B minus BW, because we are just considering these two extra parts. And for creating that, we just need to dissect the section into two parts. So for doing so, we just simply dissect our section into two parts. The first part is a just equivalent. It's very similar to double reinforced section. We consider the extra part of the top flange like the a something like a, or equivalent to area of steel in flange. In the real case, we don't have any steel in the flange, but we just assume they act like a something like a reinforced in top of the section. So nominal moment uh, for flange, the nominal moment which is responsible for the flange for these two extra part is equal to AS for flange times Fy times D minus HF, because that's applied to the half of HF over 2. That's the location of resultant force of here. And the distance is definitely D minus HF over 2. That's equal to the other part, because the other part is a concrete part, 85% of F prime C B minus BW HF times the same R. And if you, the only unknown in this equation is the area, equivalent area for steel in the flange part of the beam. So if you do so, it just gives you an equation. And if you replace the numeric value in the equation, it just gives you a 4.59 inches squared in terms of area of steel responsible for the flange part, or equivalent to flange part. And then Mn is area of steel of flange times Fy times D minus HF. And you can simply calculate the moment of nominal moment regards of flange part. That's 493.425 over here. And the other part for, so MNF is 493.425 kilopound feet, and our calculation is based off pound times inch. And if you just divide it by a convert it from inch to feet by dividing it by 12 and convert it to 1000 by 1000, that's kilopound feet, and that's this number. And the other part of the problem is the nominal moment due to web part, and that's AS minus AS of flange. We need to subtract the area of steel, like what we did in double reinforced section. If you remember, that was AS1 is equal to AS minus AS prime, or AS2. Likewise, we do the same here. AS responsible for web is AS, total AS minus AS for flange. Like, it's very similar, not identical, very similar to double reinforced situation. And that's Fy. This time my R is A over 2, because the resultant force applies at the A over 2, which is the height of the equivalent weakness block, and half of that. So, and definitely that's equal to 85 percentile of F prime C times A this time, BW, because we are talking about the chunk of the area for them this time. And the only unknown is A here. And if you calculate the new A here, we call that new A, which is related to a T-shaped section, and that's AS minus ASF times yield strength of a steel over 85 percentile. It just comes from here. And if you replace it by numeric value, we already calculated the ASF in previous part. If you just subtract AS minus that times Fy over 85 percentile, this is F prime C, and that's BW. So the only unknown here is A, and as soon as you do the calculation, it just gives us a numeric value of A is equal to 5.22 inches, and Mn nominal moment in terms which is responsible, the portion of nominal moment which is responsible for the web or regarding the web is as minus asf times fy times adr. So a moment is equal to a force times r. This is my r, and area times stress is my force. So if you replace that by numeric value, it just gives you a mnw is equal to a numeric value of 171.187 kilopound feet. And if you add these two numbers with each other, it just gives you a nominal moment of a T-shaped section, and that's MNF plus MNW. Portion of flares, the portion of nominal moment related to responsible for flange, and added up with a portion of nominal moment regarding verb or responsible for verb part. So Mn is equal to Mn of flange, and then added with Mn of verb. And if you add these two numbers with each other, it just gives you 493 plus 271, and it just gives you a nominal moment for the section equal to 764 a almost 6 kilopound feet. Thank you. We'll solve more problems next videos.